Assalamualaikum, my name is ZAIDEY. Today I'm going to present about switch mode power supply design for assignment 2. This is my group members, Muhammad FARID bin ZAIDEY and myself, Haris Daniel bin Hasmi. For the assignment 2, we need to design a switch mode power supply that produce a variable DC output voltage of 0 volt to 60 volt from a single phase AC input voltage of 240 volt RMS with 50 Hz. The rated converter output power is 200 watt. The output voltage ripple at steady state must not exceed 5%. Next, this is the circuit on MATLAB for the part 1 of the assignment. Next, this is the theoretical calculation for part 1. For part 1, we need to find the B in, which is 340 volt. Next, we need to find the duty cycle, which is 0.176. Next, we need to find the resistor, which is 18 ohm. Next, we need to find the inductor minimum value, which is 247.2 microhenry. The value of the inductor is must be larger than minimum inductor value, and we assume it is 250 microhenry. Next, we need to find the inductor current, which is 3.33 ampere. Next, we need to find the value of the capacitor, and we get 9.16 microfarad. And then we need to find the average value of inductor current, which is 6.56 ampere. And then we find the maximum inductor current, which is 6.63 ampere. And then the minimum inductor current, which is 0.04 ampere. And then we can find the voltage ripple, which is 3 volt. Next, the circuit will operate at CCM because value of current inductor minimum is more than 0. Then we find the period, which is time equal to 1/30k equal to 0.033 microsecond. And then we find the average inductor current, which is 6.23 ampere. Then we need to determine the Kp and Ki. First, we assume the Ki is 10k and the S is 30k. Then we can find the Kp, which is 0.33. Next, after the simulation, we can find out that the result is different than manual calculation. The IL max for the manual calculation is a bit higher, about 0.02 ampere higher. And then for the IL min, the simulation result shows that it has a difference of 0.06 ampere. For the V out, the simulation result is a bit lower, which is 58.56 volt. And then the V in, the simulation result shows that the voltage is 340 volt, and the duty cycle for the simulation result is 0.145. Next, for the simulation MATLAB part 2, this is the design of the circuit containing block diagrams of the PID, PWM and buck converter. Next, this is the theoretical calculation part 2. First, we assume that Ki is 10K and S is 30K. Then we found out that the Kp is 0.33. And then when we run the simulation, we can find out that the phase margin is 163 degree. And when 180 minus 163, we got 17 degree, which is not stable and not in the range. So to achieve stability, we use phase margin 135, and then to find the magnitude, we get 39.3 dB. And then we find the new Ki, which is 20 log Ki equal to 40.7 dB. And then we find the new Ki of 108.39. For the new Kp, the S we still assume 30K, and the Kp we get 3.613 milli.
First, we adjust the parameter in buck block, which is the V input is 339.41 volt. Inductor is 247.2 micro. Capacitor is 0.926 micro. Resistor is 18 ohms. Then we adjust the PI value, which is for our starting Kp, the value is 0.33. The Ki is 10,000. Okay, then we run the simulation. It take 8 seconds to complete the simulation because our stop time is set on 8 seconds. Okay, first we go to the buck block linear analysis and linear RS block, and then we go to analysis input output. We change it to model iOS, and we go to pole 0. We put the grid and we marking the each of the pole 0 value. Supposedly we use the S value from the range from pole to 0, but in our assignment value we use the value S is 30,000 as we show in the calculation. We get the S value is we get the Kp value is 0.33 and Ki is 10,000. And then we go to both plot to get what is the value for the Kp new and Ki new. So we use grid, and we need to change the frequency to hertz by using the properties here and here, hertz. Alright, then we find the 0 here. the 0. Okay, then we find the phase margin by using the same frequency at above. Okay, from the phase margin is negative 163, we change it to the negative 135. A bit. We change to the 135 to get here, and we, by using the same frequency, we find the new gain margin. Okay, 38.9, but we already find our new KP and we already did find our new KP new and KI new by using the here is we get 39.3 dB, we get the result 40.7 dB. We find the new KI by using 20 log KI equal to 40.7 dB. Then we get the KI new, and for new KP we use formula S equal to KI over KP. Then we get the new KI KP is 33.613 power 10 power of negative 3. Then then we put the value in the new circuit PID value, which is the KP is 3.613 exponent negative 3, and the KI is 108.39. Then we run the simulation. Alright, okay, and then we go to linear analysis block. Then same method, we change the model IOS. Then we go to the plot 0. We go to plot board. Okay, then we show the grid and change the properties to Hertz. Still change. Alright, then from there we find the frequency 0 dB. Then where is the 0? Okay, here. When the magnitude is 0 point something, we must get the 135 phase margin. Let me adjust the result. Here, so we can tell that our system is good. Alright, and then for next circuit, here, this is our next circuit. This is a buck converter which is use CCM. Alright, and we need to find the voltage ripple and etc, which is our parameter use the same parameter. Okay, and then I run the simulation. Before that, I just show the result. This is our result from the simulation. From the scope 1, we get this is the waveform. From the scope 1, the waveform, the scope 1 shows that due to our circuit use 30 kilohertz. This is the proof that our circuit, the simulation result use the 30 kilohertz. And the scope 2 shows how we can find the voltage ripple, which is we can find from this measurement, which is this is measurement which is 60.19 minus 57.52 and over 60, because 60 is voltage output, and times with 100 we get less than 5%, which is a very good. And at our scope 3 we find the duty cycle by using this measurement when it's turned on then and turned off, okay, which is 0.145. For manual operation we get the duty cycle is 0.176, and our simulation get 0.145, which is not too different. Okay, our simulation is done. Wait a bit. This is our scope 2 result simulation. Supposedly if we adjust the 1-2, this 1-2, we can get our frequency is 30 Hz if we adjust this measurement 1-2. And this is our scope 3, scope 3 to find the duty cycle. If we adjust this measurement 1-2, we can get the duty cycle is 0.145. 145 and 145. Duty cycle is 0.145. 145. And this is scope 1 is to get the result. Scope 1 is to get the result 30 Hz. Scope 3 is to get the result duty cycle, and scope 2 to get the result for the ripple. Scope 2 to get the result for voltage ripple. And that's all for me. Thank you.